So we're back at chapter 10, section 2 this time, talking about angles and arcs. Again, this is within circles. Okay, so everything we talk about has to do with a circle. We do have angles within circles. An angle whose vertex, remember the vertex is the point. So an angle whose point or vertex is at the center of the circle is called a central angle. Central because it's starting at the center of the circle. So here's our circle. It's actually created by two different radii. Okay, so here's the vertex of that angle. Here's one radius, here's another radius. We just made an angle. So this is called a central angle because the point of that angle, the vertex of that angle, is at the center of the circle. Now remember, we really need to name an angle with 3 letters. The vertex being the middle letter. So this angle could be named LCY or YCL. And that would be our central angle name. If we drew other central angles in here, again, if they're central angles, they have to have their vertex at that same center point. So I could draw a bunch of different central angles in here. If I were to add all of these up, just drawing them, what do I end up drawing? I end up drawing a circle. How many degrees total would they all equal if I added them up? Their sum. Their sum would be 360 degrees, as long as they don't overlap. Okay. So each individual angle, these small angles. I couldn't do this angle and then this angle. See the overlap there? This big angle with this big angle. I couldn't do that because there's an overlap here. But as long as they are just side by side and don't overlap, their sum is going to be 360. So in this picture, angle 1 plus angle 2 plus angle 3 is going to be 360 degrees. Now what if I had a diameter in here? Remember, a diameter cuts that circle in half. What would this angle be? This big semicircle, if it's half of a circle, and it makes this diameter. Well, half of 360 is 180. So a semicircle, if you were to put a bunch of angles together and they make a semicircle, we would add those up to 180. So here's a problem you might see. We know that RV is the diameter. Again, it's a chord that starts and ends on the circle, and it goes through the center, so that makes it a diameter. They're asking us to find the measure of angle RTS. So it's this angle right here. Start at R, go to T, go to S, and that angle is the one we're looking for. So somehow we're going to have to solve for X and plug it back in. Well, I see that these 3 angles right here make this semicircle. So I'm going to take those 3 angles and add them up to 180, because remember, it's a semicircle. Semi meaning half the circle. Okay, see those 3 angles there? So if I were to name them, and this is kind of hard to see, RTS plus STU plus UTV, those 3 angles are going to equal 180. It's kind of hard to see there, it's a 180. So now I'm going to plug in what each one of them is marked, how they're represented. I've got my 8x minus 4. Then I have 13x minus 3 here in the middle. And I have 5x plus 5 here on the bottom. Those are going to equal 180. Now if I add my like terms, 8, 13, and 5, because they all have an x. That's what makes them like terms. They are alike in that sense, and I'm adding them. They're all positive numbers. Then I'm going to get 26. Negative 4 minus 3 is negative 7, plus 5 is negative 2. So when I combine my like terms, I get 26x minus 2 equals 180. Now if I add 2 to both sides, and then divide by 26, my x equals 7. Now, am I finished? Does that answer the question? It says to find the measure of angle RTS right here. So no, I have not answered the question. That means I need to go back and plug that x in. So I'm going to have to plug 7 in where I see an x right here. 8 times 7 is 56. 56 minus 4 is 52. So that is our final answer. Box it in, circle it, something to indicate that's where you stop. Okay, here's another one. Refer to circle Z and find the measure of CZD. CZD is this angle right here. Okay, so what is your strategy going to be? Before I tell you my strategy, look at this circle. Look at all the pieces that you have involved here. What is your strategy going to be? What kind of chord is AD? It goes through the center. So we call it a diameter. How many degrees are in a diameter or a semicircle created by that diameter? It's 180 degrees. So again, we have 3 angles that when put together equal 180 degrees. So my equation should look something like this. 75 here plus 5x minus 5 here plus 7x plus 2 here. Together they all equal 180. Combine like terms. Find my x's and put them together. I have a positive 5 and a positive 7. That gives me a positive 12x. I cross them out so I know when I'm finished. 75 minus 5 is 70. Plus 2 is 72. So plus 72 equals 180. Now I need to subtract the 72 from both sides of my equal sign. $12x equals 108. If I divide by 12, I get 9. So here are my choices. Okay. Look, 9 is a choice. So the tendency is going to be to choose that. Remember, you need to go back and make sure you are answering your question. It says to find the measure of CZD. So this one right here. So what do I need to do to actually find that measure? I got to plug this 9 in place of the x. So 7 from here times 9 plus 2. 63 plus 2 is 65. Now I have answered my question, so my answer choice is going to be C. Don't forget to check to see if you need to plug it in. Okay, besides angles, we also have parts of a circle called arcs. What is an arc? It's a portion of a circle, the actual outside ring of the circle, cut by 2 radii. So here's my circle. If I take a radius here and a radius here, it's cutting this piece of the circle. It's just a part of the circle. So this is an arc. This green portion is an arc. This blue portion is an arc because it's made with this central angle that is actually a diameter of 180 degrees. So each color is a different arc of the circle. The arcs are related to angles within the circle. We can have minor arcs and major arcs depending on their measure. A minor arc is an arc formed by the interior of two radii with a central angle less than 180 degrees. So just know it's less than 180 degrees. Minor arc has a central angle less than 180 degrees. If it's more than 180 degrees, it's called a major arc. Okay. Or you could look at it as one is the interior of the central angle, the other one is the exterior of the central angle. Okay, so here's our central angle. Here's the center of our circle. If it's 60 degrees, this arc here that is formed by inside that 60-degree angle, this would be your minor arc. Your major arc goes on the exterior all the way around the back side of it. The measure of your minor arc will always be less than 180, and the measure of your major arc will always be more than 180. So we could add here that its measure is going to be greater than 180. And the measure up here is always going to be less than 180. The measure of this arc here is going to be equal to the measure of the central angle that forms it. And then remember, the whole circle has to equal 360 degrees, so the major arc is going to be that 360 minus your minor arc. The two arcs are going to add up to 360 degrees. So minor plus major is going to equal 360 of the same central angle. Well, what if it equals 180? Okay, so far we've had arcs less than 180 called minor arcs, arcs greater than 180 called major arcs. What if it equals 180? We've already been using this term. It's called a semicircle. And the endpoints form that diameter. So this ACB arc right here, that is a semicircle. Okay, so let's apply this information, newfound information, and see if we can find the measures of all these different arcs within this circle if we're given these two angle measures. Let's see what we can figure out here. Okay, we want to know the measure of arc AB. Well, this arc AB is going to be the same as the central angle that forms it. So that's easy. That's 80. It has to be the central angle. DE, again, is going to be the same as the degrees of the central angle that forms that piece of the circle. Think of a piece of pizza. This is the crust. Okay? The crust is the length of that crust, or the degrees of that crust, is determined by how big this angle is of your pizza. So 45 degrees. AF. How are we going to find this arc right here? Well, we have to know the angle measure. We don't know the angle measure. So then you have to ask yourself, how am I going to find the angle measure? There's got to be a way or they wouldn't ask the question. So don't just sit there and go, I don't know, and walk away from it, because you do know. You just have to think about it. And remember relationships. What kind of angles are these two right here that are created by an x of the same two line segments? They're called vertical angles, and we know vertical angles are congruent. So that means this angle is 45 degrees, which means arc AF is 45 degrees. Now we want DF, D all the way around to F. Well, DF is a chord going through the center, so this is a semicircle. It's created by the diameter. Half the circle is 180. BF, all the way around from B through A, all the way to F. I have to go from endpoint to endpoint. It includes both of these angles in their entirety. So if this is 80 and this is 45, the whole thing is going to be 125. We just add them together, angle addition postulate. Learned way back, chapter 1. So it's going to be 125. B to D, how are we going to find that? We don't have anything here. So what's our strategy going to be there? Any ideas? Okay, well, I see that these three angles together here, this 45 and 80 and our unknown, if I put them together, I make this diameter or semicircle all the way around here, which is 180 degrees. So I can take 80 plus the 45 plus my unknown angle, and together all three of those will equal 180 degrees. Well, these two are 125 plus my unknown is 180. Okay, so my missing angle is 55 degrees, therefore my arc here is going to be 55. Now, notice that all of these arcs have two letters in their name. Those letters are the endpoints. Okay, so BD goes from B to D. DE here went from D to E. Now we have one that has three letters in it. Why? Why three letters? That indicates that it is a major arc. So these are all minor. Named with two letters. This indicates a major arc. So that means I got to start at D and go to B, but on my way I got to go through F. So I'm starting at D. I'm trying to, dang it, I'm trying to go to B, but I have to go through F. So let me get a different color here. Maybe it wasn't so bad that that popped up. Let's use white. So I'm going from D through F back to B. That is definitely a major arc. That is way more than 180 degrees. So we're going to use three letters here. This is a major arc. So I automatically know it needs to be more than 180 degrees. So if I don't get a number more than 180, I've done something wrong. The whole circle again is how many degrees? 360. So it's 360 minus this part. I'm not using this part right here. So 360 minus 55 is 305. And then the last one is this FE here. How would I find this arc? Well, again, I see a semicircle. If I combine the 45 and this angle FCE, that makes a semicircle 180. So if I subtract that 45 from the 180, I get 135. And there we have them. We found all of our arcs by just knowing two angle measures. So the arc length equals the angle measure of the central angle that makes it. Okay, and here's just all the verification of what I had done ahead of time. Okay, we actually have a theorem here that says in the same or incongruent circles, two arcs are congruent if and only if, okay, this may be the first time we've seen this. When you see if spelled with two ifs, that means if and only if. And it's the only way that'll happen. Their corresponding central angles are congruent. So if we have two angles that have the same measure in their central angles, then the arcs will be the same as well. It's kind of common sense, but sometimes we have to state it as a theorem in order to use it. So just like our angle addition postulate let us add angles together to create bigger angles, our arc addition postulate lets us do the same thing with arcs. The measure of an arc formed by two adjacent, remember what that word means, you can't forget that, by two adjacent arcs is the sum of the measures of the two arcs. So if we put two arcs side by side and we know the measure of both, then the big arc that they make is just going to be the sum of their two measures. Right? So arc CA here in red plus arc DC here in blue will make this whole big arc AD. So if one is 40 and the other is 32, then together they should make 72. But remember, we need to name that new arc with its endpoints, DA. This whole big thing would be called arc DA. We would not use the C because it's not a major arc, it's a minor arc. Don't put the C in there unless you're going all the way around the backside of an angle. Okay, so here we want to find angle ABD. ABD. We're looking for this angle. Well, it's the same as the arc that it makes, this arc AD. We don't know arc AD, but we know that we can put the two together to make, we can put arc AC and CD together to make that one big arc. We don't know that they're equal to each other, so we would not want to set these two things equal. Nothing tells us they're equal. There's no congruency marks or anything, so don't do that. So we're going to add these two arcs together, and together they should equal this central angle measure. So that's what our equation is going to say. Okay, here's the measure of AC here plus the measure of DC here is going to equal the whole thing AD. And that whole arc is going to be equal to our central angle measure. So let's plug in what we know. We plug in the parts. The two arcs, 4x plus 7 comes from here, 2x plus 5 comes from here. Together they're going to equal the central angle, which is 8x. Combine your like terms. 4x plus 2x is 6x, 7 plus 5 is 12. Move the 12 over by subtracting, or we'll move the 6 over. That makes more sense. Move your smaller x. 8x minus 6x is 2x. Now divide by 2 and x equals 6. But I got to answer the question. It says find the measure. I need to take that 6 and plug it in where I see that x. 8 times 6 is 48. I could also find the arc measures if it asked me to, just by plugging them in. So again, it's all about using your relationships, setting up your equations based on those relationships. Let's do another one here real quick. I know this is getting kind of long, but I want to work examples for you. Okay, so we need to find NP. Let me change my color so we can see my markings better. Find okay, no, I'm sorry. The measure of NPM is 46. PL bisects KPM. Well, what does that word bisect means? Again, it's in bold. We can't forget that. It means it cuts it in half, so I know these two parts are congruent, so I already put my congruency marks there. But if I hadn't, you should know that, and you should mark it up like that. And OP is perpendicular to KN. Perpendicular means it forms a 90-degree angle. Find JKO. So JK Oh, we are going all the way around the circle. Okay, it is a major arc. So, a couple ways we could do this. We could find all the missing pieces and add them up. Okay, so I know that these two are equal to each other. These three are going to equal 180 degrees. Right, I could do that. Figure out what these are. So I'd have 180 minus 46 equals 134. Divide that by 2. Well, it doesn't really matter. We'll just put 134 in there. Okay. I could find this one because I know these are vertical angles, so that's 46. And I know this is 90. I could add all those together and subtract from 360. No, I wouldn't even need to subtract from 360. I'm looking for the whole major arc. So I'll just add all those together. So let's see. Just writing it out neater so you can see the actual math here without my chicken scratch. Well, come on. Okay, this is not the way I just did it, but we'll just go with the way I did it. So 46, so if I add all these together, I get 46 plus 134 plus 46 plus 90. Well, 46, again, you can use your calculator. You get 180 here, obviously, since this was a semicircle. If I add these two together, I get 136. When I add these two together, I get, what, 2, 16, is that right? 6, 8, 9, 10, 11, yeah. No, 316. So if all of these angles here add up to 316, not counting this one right here, then that means this arc that encompasses those angles is going to have a degree measure of 316. Okay, this is another approach. Oftentimes when you have multiple parts involved, there's going to be several different approaches we can take. So just go with the one that makes sense with you and run with it. Okay, let's do one more. Circle graphs. This graph shows the percent of each type of bicycle sold in the United States in 2001. Find the measurement of the central angle representing each category. Okay, so I have percentage here. I don't actually have angle measures, but we know that the whole circle is 360 degrees. So I'm actually taking 37% of 360. 21% of 360, and so on. So all we're doing is percentage problems here. We're going to take the 360 degrees of the whole thing, multiply it by 7%. Now you remember, when you're punching this in the calculator, you got to change your percent to a decimal. So you're actually multiplying by 0.07 times your 360. And that's how we got 27 or 25.2. Okay. Using that same technique for each piece of the pie, you will get your various degrees. How would you check this to make sure you did it all correctly? How would I know if I got all the right degree measures here? I would want to add them up and make sure that they equaled how much? 360 degrees. Okay, that's it for this section. Good luck on your work.